All right, so this is a little Goddard Plus extra. We have some interesting developments going on in these national areas. We're talking about international cooperation in future advanced science. And we want to thank Nota for sponsoring all of our sessions today. And welcome to Antonella, Nota, the Associate Director for ESA, Space Telescope Science Institute. Thank you.
Thank you. Can you show me how to advance this one?
As I can, if I can find it, here it is.
Good morning, everybody. Good morning. So can you hear me? I'm loud enough that I probably don't need the microphone. So my name is Antonella Nota. I'm with the European Space Agency. I am in Baltimore because we have a group in Baltimore of approximately 30 people, 30 scientists who are supporting both the Hubble Space Telescope and the James Webb Space Telescope. So I will speak as an astronomer today. And I want to convince you in these few minutes that we have that international collaboration is actually key to advancing science. And not only because it guarantees missions against cancellations and because you can have monetary contribution and all that, but because really the spirit of science collaboration is key to maximizing the output, the scientific output. So if we look, for all of you who have been spending way too much time on social media, how did it all start? And then we'll see how it's going. It started in the 70s. ESA itself is a relatively young agency. It was established in 1975. And some of you might remember the first ultraviolet mission, the International Ultraviolet Explorer. That collaboration started like a few years after ESA started. Then the Hubble Space Telescope. So the agreement was signed in 1977, 2 years after ESA basically formed as an agency. So again, this is just to show you how a newly formed young agency decided to play ball with the big guys NASA and get into this program, Hubble, that lasted 30+ years and has completely revolutionized the way we see it. So how did it all started? How it's going. Now, this is the portfolio of ESA missions in astrophysics. And as you can see, we have divided them into the electromagnetic spectrum, starting from the infrared to the gamma rays. You'll see here missions that are already operational, other missions that are in the future. But basically, what you see here, which is very important, look where the NASA midpole appears. There is a significant presence of collaboration in this portfolio. And this is the argument that I will make, that it is because of this collaboration that we can maximize the scientific output from this mission. So because I'm an astronomer and because I am fond of Hubble and Webb, this is what I will be mostly discussing today, but putting it in the larger context of why we do what we do. So,
Antonella, excuse me. We do need you to use a microphone for our online audience.
oh,
So
okay, I'm very sorry.
You
Yes.
you can use this if you want.
I can do the walk around. So I will use it. Thank you so much. So, of course, we have to start looking at the launch. Why? Because one of the contributions that ESA provided to this mission was the launcher, Ariane 5. A rocket that has been, functioning, really well for several years, 100 or more launches without a single glitch. And as a matter of fact, this launch was absolutely perfect. And the reason why astronomers like to look at launches is because it's the start of a new chapter. I mean, you guys are all interested in building things. We are too, but we're interested when things are built and they're up there, they're functioning, they're taking data, and they're doing amazing science. Of course, you all have seen this iconic picture. This was from the camera that was installed on the Ariane rocket as James Webb
moves away into space on the way to the Lagrangian point 2. I think that this was so iconic, and just the idea to say goodbye to this mission that has been taken so much energy from for so many years, finally see it on the way to exploring the universe and fulfilling the ambitious science goals that have been set. Looking at the origins of the universe, studying planets outside our solar system, studying the life cycle of stars. This is all, amazing things that Webb will do for us. And I can tell you that this is the money shot. Ariane will now put cameras pretty much on all their rockets, because this is a first, and was such an amazing result. And the launch was so perfect that the solar array deployed a few seconds before expectation, just because the condition of the launch were so beautiful. So anyway, Webb we're just waiting. Commissioning is going extremely well. We're just waiting for the amazing science. Other two contributions that ESA gave to the mission, the two of the main instruments. NIRSPEC, the workhorse spectrograph, will observe 40% of the time during the first year. And one of the things that NIRSPEC will look at distant galaxies. The one like you see here, this doesn't show, yeah, in the a sort of Hubble deep field, the very distant universe, the galaxy that formed 400 million years after the Big Bang. And NIRSPEC is able, thanks to an amazing technology that is for the first time flies, micro shutter arrays, who can take spectra of these galaxies 200 at a time. So with a maximum efficiency of information, you can just point and see all those galaxies, what they are made of. And this will tell us how they formed and they are evolving. MIRI is the mid-infrared camera. This is the one that has to work at the temperature colder than everything else, but has really interesting scientific applications in the exoplanet field and others, and has IFUs, this way of taking spectra of spatially resolved regions, so that every spaxel gives you, spectral information. So we're really excited to see these two instruments. MIRI was developed in a partnership with University of Arizona and JPL at the 50% level. So the interesting thing of MIRI had a different model from other instruments. NIRSPEC provided by ESA, MIRI provided by the European Consortium in collaboration with ESA. That means that we have now a distributed way of looking at Europe, where you can see in this map, these are all the institutions that have provided hardware to this mission. Why this is important? Because going back to the exploitation of science, when you start having a wide group of institutions that are involved in the direct development and building the mission, then that translates into usage. That translates into collaboration. And as you can see here, this is, for example, the result from cycle 1 in Europe. This is the first observing cycle for Webb. The time, as many of you know, is allocated in a very in a peer review fashion, where astronomers evaluate the significance of the science proposed by their colleagues. There is a high oversubscription, and the first cycle for Webb is already defined because this process has been run. And as you can see from this map, where you see the number of successful proposals per state, this map pretty much mimics really well the map I showed you earlier with the hardware contribution. So it's a full model, design, build, exploit. And we don't have the data yet, so I cannot tell you the impact of the data quite yet for Webb. But I can tell you that for Hubble, because for Hubble, we have been doing this for 30 plus years. And this is just an example, it's a long partnership, and the European community is really, really engaged in this mission. And you can see here a collage of beautiful pictures that was issued for the celebration of the Advanced Camera for Survey 20th anniversary, which was absolutely spectacular. You can recognize some of the iconic Hubble images that you have seen over the year. But what is most important, this iconic image translate into discoveries, translate into scientific results that are published by the astronomical community that we just explained. And so how do astronomers evaluate whether a mission is successful? You look at the number of the scientific discovery, you look at the number of papers that have come out from that mission. And if we look at Hubble, where we have 30 years of data, you can see, you can see here, if I manage to work this, from the beginning, 1991, to the last year, this is the number of publications that are based on Hubble data, growing every year. Not only growing, but if I look at the community of users, Hubble has almost 9,000 users worldwide, of which almost 3,000 in Europe. All these people collaborate together. They collaborate, they write paper together. I have a hard time finding a team that doesn't have an international component. And this is how science moves forward. So as a matter of fact, we're quite happy to see that almost 39% of the papers that are coming out have authors, first authors from Europe. So to the point again that this is so important that you have communities across the ocean working together. It's really one community. And a proof that it is one community is when these two processes, these two parallel processes have run together. In the US, the Astro 2020 Decadal Survey, in Europe, Cosmic Voyage 2050. The conclusions are remarkably similar because the top questions that astronomers are asking are the same. Do we have life out there? Are we alone? And these are the questions that the people, everybody of us is asking. You don't need to be a scientist or an astronomer. So it's not a coincidence that on both sides of the Atlantic, you had this consensus on where to focus for the next decades. And so I will conclude saying that I really think that the future is bright. And working together, it will be possible to make, to realize the most ambitious missions that humankind have seen, and really be able to all answer the key questions that we astronomers are dying to answer. Thank you.
Yeah, time for a question or two?
Sure.
Right, Antonella says she has time for a question or two, and we've got questions, so right up here. All the questions coming. When I go to the IAF and get the presentations of all the stuff that folks are doing in Europe, I'm really always amazed. It's amazing. Okay, hands up for the, yeah, we're in the red. And also there's one here. Are you got a question too there in the suit right here? Okay. Over here first.
Hi, Antonella. I'm Susan and I work at NASA Goddard. I've interacted with you several times with Tom Griffin in the past. He had me doing quite a few travel orders that involved you. So you may not know me, but I do know you and we really appreciate your talk. Can you explain your relationship between ESA and NASA?
Yes, they're partners. Basically, at the beginning, we have a very open communication between ESA and NASA. And every time NASA is thinking about a new mission, if ESA is interested, they partner. Like, for example, on Hubble and Webb is the same model. ESA participates at the 15% level. That means that ESA provides some contribution, which are hardware, but also people, because of this contingent of people that we have at STSCI, which I lead. We have approximately 30 people funded by, by ESA at STSCI. In exchange, the European astronomers have a guaranteed access to at least 15% of the observing time. Now, this is written in the legal document, in the memorandum of understanding. In reality, the competition is open and is free. And there has never been the need to enforce that number, because European, well, first because the teams are international. And so there is an international component to every single team. But in addition, people, you know, collaborate, they're very creative. And so European astronomers do really well getting time on the missions without enforcing what the MOU details. So.
Thank you. We had one over here.
Similar. Can you explain the relationship between ESA and the EU?
Haha.
Oh, no.
No, I don't. No, I don't think I can in the.
Are you
time.
volunteering? Uh-oh.
I don't think I can in the time allowed. Plus, you know, as an astronomer, I just focus on the science.
So is like Britain part of ESA, or you know,
Oh,
that's
yeah.
what I mean. Okay, so ESA isn't just the EU.
Yeah, no.
Okay, good. That's
ESA
what I
is
thought.
22 states. And for example, Britain is, as you saw from my map of earlier, is definitely a very strong participant still, even after Brexit.
Okay, last question.
You know, one of the successes of Hubble is really that internationalism, and nobody ever invoked percentages or anything like that. And, you know, I fully see James Webb as continuing in that way. Do you see any obstacles to that in the future on either side of the Atlantic?
Not at all, not at all. I think that this is something, at least on the European side, but I'm sure also on the NASA side, we have seen it's just completely open collaboration. And I think this is absolutely great. I have also to remark one thing that I didn't say, I should have said. We are talking about the astronomical community. We should talk also about the public, because the public is absolutely behind the community. And for example, for Webb, the communication on Webb that NASA has organized have been absolutely spectacular. We have jumped on that bandwagon, and now we have a community in Europe of James Webb geeks who wants. It's really scary. So I think it's really fantastic how even on the outreach part, we can work together and maximize the impact. So I think that we see that both in science and even in the outreach part.
So thank you, Antonella. That was actually rather surprising. I appreciate it.
Thank you.